Hello, I wanted to talk about variables and how we use those to solve equations. Now, as we talk about this, we're going to need to talk about these other things, but let's just go ahead and get into it. Variables. What's a variable? Well, first off, a variable is a symbol that represents another value, or represents some value, some amount. Sometimes we know what that amount is, sometimes we don't. Usually, we don't. The normal variables we use are things like x, y, and z, sometimes a, b, and c, sometimes more fancy values like these ones over here. Sometimes we use L, W, and H. These are very common in geometry, along with these capital letters down here, A, B, and C. These are also very common in geometry, and it is important to note that a lowercase letter and an uppercase letter are different variables, so they cannot be combined even if they show up in the same equation until we prove that they are the same amount. Then we have these values down here with subscripts, so n sub 1, n sub 2, n sub 3, or just n1, n2, n3, depending on how you want to pronounce them, are usually talking about related variables or values in a sequence, but they are also different numbers, different amounts, different variables, so they cannot be combined either. And then we have these ones down here. These are symbols that represent defined values, pi, Euler's number, the imaginary number. These are defined constants that use these variables to represent those amounts. So, how do we use variables? We can do addition, x plus 1, subtraction, x minus 2, multiplication, x times 3, and division, x divided by 4. Now, we can't simplify any of these, other than maybe x times 3, which can simplify to 3x, as we usually don't write the multiplication between a variable and the constant is being multiplied by. We usually combine those so that they're a term, which I'll talk about in a little bit. Now I can also use all of these operations with other variables. So I can do things like x plus x, x minus x, x times x, and x divided by x. Now, because I'm doing operations with variables with the same variable, x plus x, I can actually do some combination here. If I take a number and I add it to itself, I get twice that number. So that's actually going to be the same as 2 times x, or 2x. If I take a number and I subtract itself, whatever that number is, I'm going to get 0. If I take a number and I multiply it by itself, that's x squared. So we get the repeated addition is 2 times x, and repeated multiplication is x to the power of 2. And then x divided by x is 1. Take any number, divide it by itself, you get 1. So how do we evaluate these expressions? If I know what the value I want to plug in for x, how do I evaluate this? Well, you just do the exact same operations you would if you had that variable in place to begin with. Let's say I have the expression 3x plus 6. If I want to evaluate this for x is equal to 4, well then I just take this 4 and I plug it in for x. So rewrite the expression 3 times 4 plus 6, and then we just evaluate it. Just perform the operations. 3 times 4 is 12, plus 6 is 18. And so the expression 3x plus 4 for x is equal to 4 evaluates to 18. So let's talk about terms. A term is a group of constants and or variables multiplied and divided together and separated by plus signs or minus signs. Here's an example of 12 different terms. We've got a constant term, we've got a variable term, and we've got a number of terms that have both a constant and a variable in them. The constant, and when it's combined with a variable, this constant here, like this 2, is called a coefficient. All terms that have variables in them have coefficients, even this x over here. However, this x, the coefficient, is a hidden 1. And the reason it's a 1 is because you can multiply anything by 1 and it still has the same value. Now, the reason I want to talk about terms is because we need to talk about something called a like term. Like terms can be combined by adding their coefficients. Now, what makes something a like term? Well, 1x and 2y are unlike terms, and they are also unlike from 3x and the 3xy. And the reason for that is because 1x has an x variable in it that's being multiplied into the value of the term. 2y has a y variable that's being multiplied into it. But x and y, we don't know what their values are, or we know that they're different values. And because x and y are both being multiplied into this one here, that makes it different from both of these terms. So, because of the multiplication of the variables, we need to have the exact same amounts of the exact same variables. 1x and 6x squared are unlike terms because there are two x's being multiplied here, or there is only one x being multiplied here. However, if the exponents are the same and the variables are the same, then I can add the coefficients of these two numbers, of these two terms, and I'll have 16x squared. I'll probably go into more detail about this idea later on. But for now, I have placed three pairs of like terms on this page. One of them is this one here, 6x squared and 10x squared. So let me go ahead and highlight those. Pause the video now, see if you can identify the other two pairs of like terms. Alright, hopefully you identified 5xyz and 11xyz and 9xy and 3xy. Those are the three pairs of like terms that I've listed on this page. So now let's talk about the commutative property of addition. The commutative property of addition simply states that the order of terms does not matter when adding values. So 3 plus 4 plus 5 will always equal 12, no matter the order of these numbers. It can be 4 plus 5 plus 3, that still equals 12, and it can be 5 plus 3 plus 4, and that is also still equal to 12. So why is this important? Well, sometimes we'll be given expressions such as 3x plus 4 plus 5x. And we need to combine the like terms to simplify this. 3x plus 5x is equal to 8x by adding the coefficients, or if we remember that it's repeated addition, then I'm adding 3x's over here and another 5x's over here, and so I can add each of those together, and I am adding 8 total together. Now I can't forget the plus 4 that is here. So 3x plus 4 plus 5x is 8x plus 4. Now, why am I only talking about the commutative property of addition? Why not talk about subtraction? Well, because when we're talking about subtraction, that the order does matter for those values, right? 3 minus 4 is not equal to 4 minus 3. However, 3 minus 4 is equal to negative 4 plus 3. And this is where we're considering this to be addition, because this is a positive 3 and a negative 4 that we're adding together. And so the order of the terms doesn't matter in this case. If you ever run into 5x plus 4 minus 3x, then, to combine the like terms, we have to consider the sign as being part of the term. And so this is a negative 3x that we're adding to positive 5x to give us 2x as a final result plus 4. Alright, we're very close to solving equations now. Let's talk about the properties of equality. If I start with x is equal to 4, then if I perform any operation to one side of the equation, I need to perform that same operation to the other side of the equation in order to maintain equality. So, if x is equal to 4, and I want to try to add 5 to one side, I need to add 5 to the other side. Because remember, this x equals 4. So if I add 5 to 4, then I also need to add 5 to 4 over here, so that I will have 9 on both sides of the equations. This is still true for subtraction. So if I want to subtract 3 from both sides, 4 minus 3 is equal to 4 minus 3. X is equal to 4, so this is 4 minus 3, so that's equal to 4 minus 3 over here. They're both equal to 1. Same with multiplication. 4 times 8 is equal to 4 times 8. And x, or 4 divided by 2, is equal to 4 divided by 2. As long as I perform the operation on one side and the other, then I will maintain equality. Alright, so let's talk about actually solving an equation now. Let's take this expression, or this equation rather, 3x plus 6. If I want to figure out what x is equal to, I need to perform operations in order to remove important things from the left side of the equation where x is. So, this x here has a 3 that is being multiplied to it, and a 6 that is being added to it. Now, it is usually best to start with removing any other terms from this side of the equation. So let's get rid of this constant term. Let's get rid of the 6. So if we subtract 6 from both sides of the equation, then we will know what the left side of the equation is before we added the 6 to begin with. And so we'll have 3x is equal to 18 minus 6 is 12. Now, we see that this is a 3 times x, so we need to divide by 3, and that will tell us what x is equal to before we multiply it by 3. If you take a value and you multiply it by something and then divide by that same thing, you'll get back to where you started with the exact same way when we took 6 steps forward and then 6 steps back, we got back to the same thing. These operations cancel each other out. And so we end up with x is equal to 4. And we can check this by plugging this 4 back into the beginning. 3x plus 6 is equal to 18. Replace the x with a 4. 3 times 4 is 12, which we saw right here, plus 6 is equal to 18. Now we saw up here where we had constants on both sides of the equations. So if we remove the equal amount of constant from both sides of the equation, then we'll be just left with a variable and its coefficient and a constant on the other side. And we just divide by that coefficient. So let's take a look at another equation here, a slightly more complicated one. 2x minus 3 plus 7x is equal to 9 plus 5x minus 4. The first thing we should do is if we see like terms that we need to combine those. So 2x and 7x is 9x, and we're still subtracting 3. And on the other side of the equation, we've got a 9 and a negative 4. Well, that's a positive 5, and we still have a positive 5x as well. Now, we need to pick, when we have variables on both sides of the equations, we need to pick which side we want those variables to end up on. Now, I usually like to pick this based on the larger value of the coefficient. This has a 9 over here, so I'm going to subtract 5x from both sides of the equation. I can add, subtract, multiply, and divide by variables just like I can with with constants. And so if I subtract 5x, 5x minus 5x is 0, so we cancel those out, and 9x minus 5x is 4x. Now we're still subtracting 3 from this side, and we have 5 over here on the other side. Now to get rid of this subtracting 3, I need to add 3. And we'll find out what 4x is equal to before we subtract it. And that 4x is equal to 8. Now, since there's 4 x's over here, if I want to know what one of them is equal to, I divide by the amount that I have. 4 divided by 4 is, well, 1, and I'll be left with 1x, and 8 divided by 4 is 2, and therefore x is equal to 2. And to check my work, we plug that 2 into the equation. 2 times 2 minus 3 plus 7 times 2 is equal to 9 plus 5 times 2 minus 4. Well, on the left side of the equation, 2 times 2 is 4, minus 3 is 1, plus 7 times 2 is 14, plus that 1 is 15. 9 plus 5 times 2 is 19. 5 times 2 is 10, plus 9 is 19. Subtract 4, and you get 15. Any other value of x would give you different numbers on either side of the equation. Alright, so we needed to talk about all of the things that we talked about here. Variables, what are they? Simply a symbol that represents another value. Terms, a collection of constants and variables that are multiplied and divided together. The commutative property of addition, which is what allows us to combine like terms even when they're not next to each other, because the order of the addition is not important. You can add things in any order you want. Now remember that the sign is important. You must carry that sign. So if you're subtracting a term, then consider that as adding a negative term. And the properties of equality are what allow us to actually solve the equations by taking an action on both sides of the equation. We can add, subtract, multiply, and divide things, both constants and variables, in order to reduce the equation down so that we have a single variable on one side of the equation and the constant that it's equal to on the other side of the equation. In future videos, I'll go over more examples of solving equations and go into a little bit more detail than I did in this first video. So, I hope this helps, and I will see you in the next one. Make sure to like, comment, and subscribe if you have not yet done so.